order delivery, right? It is you, right? You asked me, why on earth would I do this, right? If I want to ensure that all these messages are processed in the same order as I'm publishing, right? What I would do is I would say, hey, I'm a producer B. I would publish everything to only one partition, which is partition 3. And what happens is that all the messages get persisted in the same order, and they're immutable and sequentially stored, so the messages are consumed exactly in the same order. That's something you can't really guarantee when it comes to JMS. That's one of the reasons why you would like to do that. Maybe it's all, well, if you're probably building a system where you're processing payments, which is what I used to do a few years ago. So you get all these statuses of payments that are sent over to a JMS infrastructure as and when they are getting processed, or they go to a different state. And it's actually very crucial that the messages are processed in the right order. If you're going to process them out of order, it's really difficult. I had to do these kind of event correlation and all that. It's a nightmare, you know. But with this, you can actually achieve that very quickly and very easily. Okay. Right. That's unordered delivery is something that's a fact of life in traditional JMS. Yeah, that's only if you have one publisher, one queue, one channel. That's the only time you can achieve. Okay, throttling. This is a very interesting question that people ask me. Do I have to throttle Kafka? Well, no, because Kafka stores all these messages. You don't really have to throttle the rate at which the producer is producing messages and the consumer is consuming messages, because hey, you're having the Kafka system is acting as a shock absorber. The reason why it's used as a shock absorber, it means that it's not going to really stop the problem. It'll also blow off at some point, but you got it's a bit lenient, you know. You got a safety net till it really blows off. Performance benchmarks. This is something done by Microsoft. So if you're interested, you can go to this particular link and then find out a bit more about this. But this is basically what they found out. Yeah, key benefits, blah blah blah. I mean, he actually went through this. I'm going to let you go and read the slides later on if you're interested. I'm just not going to read them. Yeah, when would someone like to use Kafka? It's one of the three key questions. When would I use it? I mean, when would I choose Kafka over JMS or whatever? Then the first one is stream processing. When you're having a stream that is getting massive volume of data and is coming at a very high speed, you may want to use Kafka traditionally for event sourcing. And if you're tracking the activities of a website, for instance, if your website is actually very popular, like Twitter or LinkedIn or something like that, this is where this is the original use case of Kafka, because they wanted to really find out, hey, what are people actually doing on LinkedIn.com, and they wanted to have this JMS queue which couldn't really handle that particular traffic. So if you have such a busy website, you may want to think of putting Kafka in there. Metrics collection. So if your servers are, if your servers are running all the time and you're doing some sort of log analysis and all that, you may want to think of using Kafka. Okay, enough of theory. Let's try and get our hands dirty. So you can download Kafka from this website. It's basically, this is how it looks like. It's a zip file or a tarball. You can just extract it, and yeah, it's a bit blurry, isn't it? Anyway, there's this bin directory. You see a bit of shell scripts in there. Just extract it, and you would see that Kafka comes bundled with Zookeeper. Well, over here at the bottom, you see some of the shell scripts over here that says Zookeeper stop, Zookeeper server stop, and Zookeeper shell. So what I'm trying to show you over here is that Kafka comes bundled with Zookeeper. But funny thing is that Kafka is trying to ship itself with a default implementation of Zookeeper. So the Zookeeper that you see over here is a single node Zookeeper. It's not really clustered. I'll tell you a bit more about Zookeeper and why it's bundled and what it does and all that in a minute. So specifically, you have a set of code producers and you have set of consumers. Producers are sending messages to Kafka, consumers are reading messages, but then somebody has to keep track. Like if one of the servers go down, for instance, let's say you're dividing your particular topic into 4 partitions, and then one of them goes down on, let's say there's broker 1 and 2. Broker 1 is the leader for partition 0 and 1. Broker 2 is the leader for partition 2 and 3. And broker 1 goes down, you may want to have broker 2 take over that particular role. So Zookeeper over here is constantly exchanging metadata with producers, with Kafka, and consumers. Okay. So what it does is it handles outages, it handles coordination of tasks, and blah blah blah, and it also gives some sort of consistency guarantees. What Zookeeper does is it maintains primarily all the configuration information, which is what I referred to in the previous slide as metadata. So all the naming that you talk about, let's say if I'm a new, I'll actually show you all these things in action, so it'll start to make more sense. So if you don't understand entirely what I'm saying right now, please bear with me. You will get to ask all your questions and have them clarified later on. So let's say I'm starting off a Kafka cluster. The first thing I really have to do is to start Zookeeper, because if Zookeeper isn't up, the Kafka broker wouldn't have any system to communicate its metadata. It won't be able to say, hey, well, the Kafka server is up, it has got these many number of brokers, it's got these many number of topics, and all that information. So the Zookeeper has to be started first, so it keeps track of naming, distributed synchronization, and all those group services. We'll see that in a bit, yeah? 2 more slides about Zookeeper. I think it's kind of nice to know what it does, and then we'll go and see some code and demo, yeah? So Zookeeper is also a distributed data store, but with a very, very important difference. It is not, are you guys familiar with the CAP theorem, yeah? Consistency, availability, and P? Exactly. So this one prefers consistency over partition tolerance and availability. So it says, you know what, I am still a distributed system, but consistency comes first. So everything that you talk to a Zookeeper first goes to a Zookeeper server. The Zookeeper server is the only one that can do writes. Everything else is only going to read and serve read requests. Read from the server and the leader, and then and then serve all the read requests. And it is primarily meant for read-heavy write-light workload. So it's really the opposite of Cassandra. Cassandra is for write-heavy, read-light, or not. The read is not as fast as write in Cassandra, but here the reads are much faster compared to that of writes. And the data that you provide is strictly ordered. So if you're sending metadata information, so everything that you talk to Zookeeper is all strictly ordered, so it's not processed out of order. Yeah? So in short, a Zookeeper service is an ensemble with a server over here acting as a leader, and there are several followers. So all the write requests go to this particular server that acts as a leader, and all the read requests can be served by any of these servers, because these servers passively listen to the particular the elected leader over here, and then say, okay, well, the leader got some data, I'm going to listen to that particular data, and then I'm going to replicate the data. So the next time this client wants to get some metadata information, let's say I'm a new client, I'm just coming up and I'm connecting to a particular topic, and I want to know, hey, where's the broker, how many partitions are available, which partition can I listen to, which group can I be a member of, and all that. Then I can just connect to any of the servers. It doesn't really matter. Yeah. So yeah, obviously one node at a time will act as a leader. You cannot have more than one leaders, because only one node does all the write request handling. And if the leader goes down, Zookeeper will find out, hey, you know what, the leader is down. So it's only that point of time that you will have a system downtime, so to speak, because the clients and the Kafka broker and and also the also the publishers wouldn't know which Zookeeper instance to talk to, but then you can have active-active configuration or active-passive configuration for Zookeeper as well. But that's all Zookeeper internals. I'm not going to go much more into the Zookeeper. I'm going to, yeah, it's basically what I just said. Yeah, it maintains a full session and all that. It's basically what I just said. So nothing more over here, but you can read it later if you like. Okay, so as I just said, the first thing we do over here is we go and start Zookeeper. Yeah. So what I'm doing over here, once you download Kafka, and then you extract that particular directory, and then you go to the bin directory or bin subdirectory, and there's this Zookeeper start shell script. You have to provide one parameter over here, which is the configuration file for Zookeeper, and then you start it up. This is what happens. And the next thing is I'm setting up a cluster with 3 brokers, which is, I mean, this is something I did on my local machine, so I'm just showing you what I did, and we'll get to see it as well. So first what I did is you get to, if you go to this particular Kafka config directory, you will find something called server.properties, which is like the default server.properties. So what I did is I just copied it 3 times and called it server 1, server 2, server 3, because I wanted to create 3 brokers for the sake of this experiment. So what I did over here, sublime text you see, the first one I gave a broker a particular ID. You can give every broker an ID, and then you can say, hey, what are the ports that the brokers listen to? That's an interesting parameter. This is something that you can also say, hey, because all the things that you send to a particular broker as a publisher is actually persisted to a file. Yeah. So then you have to say where on earth would it actually store all the data that you're publishing, and where is it consumed from. So these are the broker's log directory, and the reason why it's called log directory is commit log. It's called log directory, and the number of petitions for this particular broker. So far so good. Yeah. And you know, I did the same thing for server 2 and server 3, but just give another broker ID and all that. These are the things that you may want to start with. Well, they say try and keep the number n to be an odd number, so something like 3, 5, or something like that would be, so that if n minus 1 by 2 nodes go down, that's the number of availability that you'll have. So that's just the same thing with any sort of distributed system. It could be the same concept in Cassandra. If you have n nodes, how many? What is the level of fault tolerance that you expect? Say, if you have the number of petitions here to be 2, then what happens is whatever I write to server 1 gets also written to server 2 and server 3. And if server 1 goes down, I still get the data from server 2 and server 3. But yeah, it really depends on the load and the fault tolerance you seek. But just try and make sure that n is always odd. It's not an even number. It doesn't make sense to have n as even. Well, I created 3 versions of server configuration files. Now all that I have to do is, well, start server 1, because here what I'm doing is I'm invoking the shell script Kafka server start, and then I'm starting server 1. I'm doing the same thing for server 2 and server 3, just pointing 3 different configuration files, and then you have 3 brokers up and running.